Hello, everyone. It's nice to be back here on another episode of On dotnet Live. We will have 60 minutes of unscripted dotnet entertainment. Our mission is to empower the dotnet community to achieve more. And I see we have people from all over the world, but I'm your host, Maira Wenzel, with my co-host, David Pine
Hello.
and Cecil Phillip.
Hey, everybody.
And I'd like to welcome today's guest, Ian Griffiths, who's going to be talking about modernizing RX.net. But before
Hello.
we jump into that, I want you to just introduce yourself and share a little bit about yourself with us.
Okay, hello, my name's Ian Griffiths, and thank you very much for having me on. So I am a long-time .NET guy, so I've been using .NET since before first version 1 shipped. I am the author of the O'Reilly Programming C# series of books. I was one of the first Pluralsight online content authors, and I do a lot of consulting. I used to specialize in WPF work. These days I've moved more into kind of data analytics type spaces, and these days I work for a company called Engine, who are also the sponsors now of the RX.NET code base. So it's thanks to them, thanks to my bosses, that we actually are able to talk about this today. So I have a deep love of computing. I've been in it playing with computers since I was about 6, which takes us back a very long way given how grey my beard is. But that's me.
Awesome. I like the extensive curriculum, and thanks for your boss for paying for for sponsoring your project. But let's start maybe from the beginning and share with our viewers that maybe are not familiar with RX.net and like does it do, what it is, and then we can go from there.
Yeah, so RX, in my view, is as fundamental an idea as something like an array. It really is that basic. It does something that is vitally important to computing and has for years been kind of underserved, to be honest. So I would say RX is useful in any program where things happen. Do you write programs where things happen?
Anywhere.
And let's be honest, not all programs are like that. There's a lot of stuff that works around batch processing where data is there and you do stuff to the data and new data comes out of it. Nothing's really happening there. There's data there, there's data there afterwards. It's more of a kind of a process. So not everything needs this, but certainly any kind of user interface based program has absolutely huge amounts of things happening and you need stuff to happen in response to that. And that's possibly where RX is best known, but it's also really useful in things like Internet of Things type applications. So at Engine, we've worked with it in utility companies, for example. So we worked with a major broadband network provider using RX to represent the diagnostic information that their broadband network was able to provide. So you had literally millions of customers with broadband devices in their homes, and every single one of those routers in people's houses is able to generate huge quantities of telemetry about how things are going. And they wanted to do things like anticipate when there were failures coming in the network, but also to be able to do kind of multi-level analysis so that they could tell when they were starting to get a bunch of faults from certain devices, whether it was just at home, if someone accidentally spilt beer into their router or something, or was it actually a fault at the exchange? Because what you don't want to do is send 30 people out in vans to 30 houses when there's actually a fire at the exchange. That's the wrong response. So that ability to manage large quantities of individual information streams and perform analytics that kind of work both at the global level, but also are able to remain active at the kind of individual source level as well. That's a thing that RX is able to model in a way that few other things can. So it's, like I say, useful anywhere things happen and you need to do something about that. So it's fundamentally important. It's like, it's amazing in a way that computer languages didn't have a way of doing this in the past. And Microsoft invented this back in the late 2000s, so around about 2008, 2009, this stuff was brewing away. And I honestly think it's one of the most significant contributions that Microsoft has made to the world of computing. And you can see how big it is by the extent to which it's been embraced outside of .NET. You look in the JavaScript world in particular, RX is extremely heavily used because it is just such a perfect way of dealing with this ubiquitous problem. So I quite like it, in case you can't tell.
Yeah, you said something that I kind of wanted to tap in on, and you said fundamental. And when I think about fundamental .NET, I think about things like Link as an example. At least in 2023, like Link is like a fundamental thing. And when I look at RX and I look at Link, and you kind of like turn them sideways and like squint a little bit, like they kind of look like the same thing, right? They follow similar models and have similar API structures. But I feel like Link has been, maybe just because it's in the box, Link has been more like adopted by a lot of .NET developers. Why don't you think the same thing has happened with RX in the .NET space?
So I would start by saying that Link is many things, right? So there's Link to objects, there's Link to entity framework, there's Link to XML, and you can use Link on all sorts of things. And RX was one particular Link provider. But I think the way I would sort of cast what I think you're saying is that of all the Link providers out there, whether it's data access with a relational database or whether it's just working with objects in memory, RX has been less strongly adopted, I think. And why is that? I think part of that, I would say, is probably that it's not in the box. It's not a thing that's right there. You have to go and look for it. I also think that it is, there's a learning curve. It's not necessarily the easiest thing to understand how to use effectively. It's a thing where once people get it, they tend to absolutely love it, but there's a bit of a journey getting to that point. you have something of a kind of a eureka moment where you just go, oh, this is how I'm supposed to use it, because it feels very different from how we're accustomed to dealing with bunches of things that happen. Because as developers, a lot of us are accustomed to, imperative code that does one thing after another. So if you're processing events that happen one thing after another, it sort of feels like you just do that with normal looking code. But actually, Link in general, and RX is no exception to this, encourages a much more declarative approach where you describe the way you're processing sets of information. And in a relational database, that might turn into a query where the database is processing entire tables at a time. In RX, it turns into sequence processing, but it's expressed declaratively. And I think it takes a while to get used to, in the same way that I think relational database programming takes a while to understand, right? It's so ubiquitous, it's so common that a lot of people understand it. Although I think actually maybe these days, with document databases becoming more popular and kind of the cloud pushing certain other kinds of storage models a bit more than the relational model, maybe not all developers do understand relational databases in the way that they probably did 15 years ago. But I think it's an interesting example, because until you understand how to denormalize your data and how to structure things in a way that works the way the database wants you to work, it's actually quite hard to be effective. But once you get it, it's enormously powerful. And I think RX is that kind of thing. So I think it is the combination of the fairly steep learning curve and the fact that it has never quite become perceived as mainstream. Those two things have probably meant that it's always been a little bit of the less strong relation. So yeah, I think those are probably the main reasons. But then it has been adopted in the JavaScript world, and I think that might be partly because one of the easiest ways to see why RX is useful is in a user interface application, because there you are absolutely dealing with events, and there is a very visual outcome of doing so. You can see right away that this connection from this source to that output has had the effect that you wanted. And so it becomes really easy to experiment with it and to understand whether what you've done worked. So you have this very tight feedback loop that helps you to learn it if you're doing user interface programming. Whereas I think it's harder to learn in other environments, I think. So I think that probably is part of the reason as well.
Yeah, I guess when I think about where I've seen it used, and I agree with you 100%, I've seen it a lot in those UI-based things. So whether it's UI in the browser or on a mobile app or even a desktop application, right? And I would even say, when I look at it from a JavaScript perspective, a lot of the times, if anyone here is an Angular developer, right, and you're using their HTTP client, right, like there's a lot of RxY things, right, like kind of attached to it. But the thing I was always surprised about was, we as .NET developers are looking at other people use it, right? Like they have figured it out, but for some reason we just haven't cared enough to attach to it, right? Because I would assume that they would have less information than we did, right? Because it came from us first, right? We gave it to you, thank you very much, right? But then now we're kind of just watching other people do it. So I mean, I agree with you. I think it's an education thing. I think it's a where am I going to use it thing, show me how to do the thing and then I'll figure it out after that, right? And so I'm hoping part of this conversation would be a little bit of you talking to us about what are things people need to know about RX on a fundamental level, and then also what are some of the new things y'all are doing to modernize it a little bit.
Well, on that note, actually, one of the things I wanted to talk about is that we are trying to do a better job of education. So quite a while ago, there was a guy, I think his name is Lee Campbell. Let me just check I've got the right name for him. I know I've lost the page. I had his name written down. I think it's Lee Campbell. He wrote a thing called Intro to RX.com. And that's still up there, but it was written about 10 years ago. And so it feels a little bit out of date. So we at Engine, as well as taking over the ownership of the .NET project up on GitHub, we also approached him and said, look, would you mind if we rewrote this? Would you mind if we updated this and kind of brought it up to speed? Because it's a good starting point, but I think it's people have found it. So when we first announced the latest release of RX, some people on Reddit said, well, I found this thing here, but it seems to be from 2012. What's going on? So it's yeah, we should probably fix that. So yeah, definitely education is a big issue. And, as a book author, as a Pluralsight author, and a former in-person instructor back when people used to learn things by going into a classroom and listening to someone, I really enjoy explaining stuff. I have a passion for teaching things, so it's one of the things we are hoping to bring to this picture is getting better explanations out there.
And I
Right.
think we all work with documentation here in the past, and we know how important it is to like have that material. And part of the mission of this show is also to give that platform to folks to get their projects out there and have more visibility. And I was wondering because I don't know a lot about the history of RX, and you mentioned Cecil. So is that something that started with Microsoft and then became a community project later?
Yes, so it originated actually with a team called the Cloud Programmability Group. So this was headed up, well, yeah, it was one of the main people behind it was the same guy who invented Link, actually. Whose name I've just blanked on, but he's a very well-known academic in the computing world, and he worked for Microsoft for quite a long time. He was also partly involved in the development of async and await. I
I
can't
think that
believe
was Eric Maira was his name.
That's him, Eric Meyer. Yes, so I can't
Mhm.
believe I forgot his name there. Yes, Eric Meyer. He was one of the big brains behind this. And what they were trying to do at the time, the remit of that group was that Azure was coming at that point. It was very new, and one of the concerns Microsoft had as a whole, as a company, was how on earth are people actually going to use this? It's incredibly powerful having this cloud platform that can do all sorts of things for you, but how do you actually build software? How are we going to tell people how to use this? And one of the things they wanted to be able to do was to simplify development of software at multiple different layers in the system. And what they actually invented looks a lot like what we now call Blazor. They invented that 10 years before Blazor shipped, and they called it Volta. And it was a very similar architecture. And one of the things that they actually needed was this ability to pass events from one layer to another. So if you had code running in a web browser or on a mobile phone, they wanted to be able to have events like we know new and live in .NET, it's events that tell you things have happened, button clicked, this has just been loaded. They wanted those to be able to flow across machine boundaries so that if you wanted the logic to run in some tier in the cloud, you could do that, but without having to suddenly go to a totally different programming model. And back in, 15 years ago, that wasn't an option. If you wanted to go across the network, you had to deal with sockets or at least HTTP, which is a totally different sort of a thing from a .NET event. And they said, well, how could we build an abstraction that is able to represent event-like things, but which is also formally well defined enough that it would be possible to make it transfer across machine boundaries without losing anything. That was actually the goal. That was actually the motivating idea behind developing RX in the first place. And then they developed the abstractions around this, and the iObservable and observer interfaces that are the core of what RX means came out of that, and that was the start of it. And then they realized that actually, in a sense, it's very similar to like an IEnumerable. An observable sequence is just one thing after another. The only difference is that with an IEnumerable, I, as the consumer, say, and now I'd like the next thing, and now I'd like the next thing. You for each over it. It's a so-called pull model. You pull the next item out of the collection when you're ready. RX, it's still just a sequence of objects. The only thing that's changed is that the source is saying, I've got a thing for you now. I've got another thing for you now. It's pushing data at you, but it's still basically the same model. It's one thing after another. It is a sequence of things. And so they realized they could actually build the entire same set of link abstractions over RX as were available for IEnumerable. And that then kind of, from there, the RX project grew out. Now, the Cloud Programmability Group sort of turned into other things, but this project survived, and actually was one of the first Microsoft projects to be open sourced, I believe. I think it was originally the Outer Curve Foundation, as it was back then, and it was up on Codeplex,
Codeplex.
I think.
Yeah.
Complex, yes.
Yeah, now it's on GitHub, of course, as you'd expect, but that it was on Codeplex first, and so yeah, it was. I think part of the reason it has endured is that because it was designed for quite different scenarios from how it ultimately got used. They had to come up with an idea that was going to endure. So abstractions that were actually really well founded and that would pass the test of time. And that, I think, actually is the key to its success. They really thought hard about what the right abstraction was, and that is the foundation of everything, really. Good foundations are what enable longevity.
So you talked earlier before about like it being fundamental to almost every type of application you're developing, and you're talking about the history. We've got a question coming from Facebook. Muhammad's asking, what are just like the general benefits of using it? You kind of differentiated IEnumerable versus, IObservable, and one's pull-based, one's push-based. So what are the benefits?
What are the benefits of using RX for event handling? I would say that the answers to that kind of fall into two categories. One of which is that RX, because it's kind of systematized, there's a standard way of doing things, it's possible for them to provide tools that solve certain problems generally. So one problem that comes up with events in user interfaces, for example, is something tells you a thing has happened. So let's say you've got, I don't know, some sort of medical device monitor sends a message saying, here's the latest oxygen reading on this person's blood, with a little clip-on thing, or whatever it might be. And the software needs to respond to this, but that message could come in on some random thread, right? You've no idea what thread the library is going to give it to you on. And most user interface frameworks don't like that. If you try and do things to the user interface on the wrong thread, if you're lucky, they'll throw you an exception. But in the worst case, they might just break in subtle ways and just go a bit wrong thereafter. And so RX is able to say, well, we have a way of solving that by saying you can just take any observable source and say, I would like to observe this source in this particular context. So you could say, I've got like a WPF window, and I want to observe events from this source in that window's dispatcher. So it'll make sure it goes onto the right thread and all the right things happen. And there's a different one for Windows Forms. And the Avalonia team have built one that works for their UI. And there's one for UWP. Anyone can write their own because it's very clear what you do. You just have to provide an RX operator that abides by all the rules and then does whatever you need it to do to deliver notifications into the right context. So it's kind of that orthogonality means you can separate out an aspect of a problem like getting things onto the right thread. You can separate that out from what am I actually doing with my data? And that then leads me on to the second part of my answer to this, which is that one of the big things that RX enables is composition of different techniques. And actually, if I may, I'd like to show an example of this to illustrate the kind of thing I'm talking about. So I've got Visual Studio Code here, and I've got the Polyglot Notebook extension installed, and I'm just going to run this notebook, and I'm quickly going to tell you what it does first before I start showing you the code. So you can see I've got a map here, and if I zoom in on Norway, what's going to happen in a minute is we're going to start seeing lots of little markers appear around the coast of Norway, assuming my demo actually runs correctly, that are going to show me where ships are sailing around the coast of Norway. I'm going to take a quick peek at the execution status of this to see if it is actually running. How far have we got? Okay, it's taking 30 seconds to download a package from NuGet. That is a good start to the demo. Right, I'm going to close and reload this because that doesn't normally happen. Let's try again. Oh, that's very weird. Why is it already running a program when... Okay, I think this has gone a bit weird. So I'm going to quickly kill that and restart it. If it will let me. That's the problem with running your demos before you turn off the talk, is that sometimes they then don't work afterwards. Right, so this was that folder there. Right, so let's see if this will work this time. So I'm going to open up this notebook, and hopefully this time it won't be under the impression that all the cells are already running. All right, that is looking better. If we can get past this one, there we go. So, all right, well, since I've had to go back to the start, I'll tell you what it's doing. I'm going to run everything. So this is using a library called AIS.NET, which is also an open source library maintained by my employer. So thank you again to Engine for this. So what this does is it connects to a public service generously provided by the Norwegian government who provide a thing you can subscribe to that tells you when ships are moving around on their coast. So AIS is the automated identification system.
That's awesome.
It's basically GPS that receivers on ships are required by law to broadcast their location, their speed, their heading, and various other bits of information to operate in most international waters. So anywhere you see ships, you will be able to pick up AIS messages by just sticking appropriate receiver up in the air. And the Norwegian government just runs a service where you can connect to a well-known IP address and a certain port number and start receiving messages. So our library provides a kind of a client on top of this, which then wraps it in RX. So you get an RX observable stream of messages coming from ships moving around from whatever server you've attached from, which is all of Norway in this case. So we've then just loaded Bing Maps, and if I scroll down, I'm hoping, there we go. Do you see? Oh, stop that. Do you see the little arrows
that's
moving around?
awesome.
So that's all live data. That's all happening in real time. So they gradually more and more will appear. Because one of the challenging features of this sort of data source is that when they send messages, they don't send all the information all the time. So there's several different types of message a ship can send. So there's a navigation message, which will say, I'm here. I'm pointing this way, I'm moving that way, because when you're on the water, those aren't always the same thing. And I am going at this speed and basic information like that. They don't always tell you their name because ships tend to move more often than they change their names. And so it doesn't necessarily make sense to include the name in every single message that they send. And so there's different kinds of messages. And so one of the challenges, if you want to maintain a map like this, is to kind of reconcile those two diverse streams. So it's like this thing, Amber Spirit here, you've just seen appear. Well, it's told us its location, but it probably told us its name a few minutes ago. And so we've had to kind of hang on to that. And so logically, you've got like a stream of my name is this type messages. And you've also got a stream of I am here messages. And we want to reconcile that onto the map to say, I am here and my name is this, so I can label the things on the graph. And we've achieved this using RX. If I scroll down a little bit and start to show you what this looks like. So I've had to do a certain amount of jiggery-pokery to enable an interactive map inside a notebook. So we'll just ignore all that code. That's just to make things work inside of here live. It's a little complex, but it's quite a good illustration of how you use RX. I'm just going to crank the font size up a couple of notches. Right, so that's the receiver host. That's the AIS.NET library wrapper that Engine provides, open source project, and it has a messages property. And if I mouse over that, you can see it says I am an iObservable. For some reason, the notebook doesn't show me the type of message. I can tell you it's iObservable of IAIS message. So iObservable is the fundamental interface of RX. It is the thing that any source of events implements. So this is a source of events. So I could subscribe to it. If I did subscribe to it, I would be somewhat overwhelmed. Actually, let me just quickly show you what that would look like. I've got a separate program here written in Visual Studio that uses the exact same source. I'm just
Could you zoom in a little bit on this one, Ian?
Yes, sorry.
Thank you. No, you're good.
Get these things out of the way so the space is all used properly. Right, so I've got a few different things in here I can show you. So this, I'm going to show you first of all the rate at which messages are coming in. So if I uncomment that one and comment these ones out and run this, I hope it will tell me every, oh no, that's going to tell me every minute. That's far too slow for demo purposes. Let me back that one out. Let's do this 10 times a minute. And also there was an error in there. Oh yeah, let's just lose that. Right, okay, sorry. Ready to go now. So this is every 0.1 minutes. I've asked this thing to tell me just how many messages it's received from that source. So that's every 6 seconds, 113. So multiply that by 10. There's about 1,000, somewhere between 1,000 and 1,500 messages a second coming out of this source. So it's relatively busy, right? So there's quite a lot going on here. There's quite a lot to keep track of. And so if you just subscribe to this and just, printed out messages, it would just be going, you'd just be drowning in data and it will be completely incomprehensible. So what we tend to do with RX is that we use operators to kind of manage the data. We can use various link operators to process it with a bit more sanity. And I'll get back to the map, but I want to show this one first because this shows things broken down in slightly more detail. So if I uncomment this one, here I'm using group by. So this is a standard link operator. You get this in link to objects, you get this in link to entity framework and so on. And this basically says, I got a bunch of things here, happens to be an observable sequence of AIS messages in this case, and I'd like to partition them into groups, and I'd like to group them by the vessel identifier. So the MMSI is something like, I can never remember, marine, mobile, something information. I mean, the S probably doesn't stand for something, but it may as well do. So it's a unique identifier. Each vessel, each ship has its own different ID. So what this does is it partitions the fire hose of messages coming from all the ships in Norway. It partitions them into groups with one group per ship. So I get an observable of observables at that point. So every time it sees a ship with an ID it hasn't seen before, my top level observable is going to emit a new group for that ship and that ship alone. But that group is then going to emit an AIS message every single time that particular ship broadcasts a new message. So then, armed with this, I can do things like ask, well, when does the ship change its status? I'm going to run this now because this actually produces messages quite slowly often. So I'm going to move that off the screen while I talk about this, and hopefully it will produce a response by the time I'm done. So what are we doing here? Well, here I'm saying, okay, well, I'm aware that there are several different types of messages. So I'm going to focus in on a certain type of message that I happen to know reports the navigation status of a ship. So that tells me things like, is it moored? Is it moving under its own engine power? Is it sailing somewhere? Is it being towed by a tug? Is it fishing? It's got lots of different, well-defined statuses the ship can be in. And the navigation messages, so the ones that tell you where you are, which way you're pointing, how fast you're going, also happen to report this navigation status as well. But it doesn't change very often. Ships don't tend to sort of flip back and forth between being moored and anchored and sailing and fishing all that often. If you think about what a sailing boat does, it will be moored in the morning and then it will start sailing out to sea, and then it will be fishing for several hours, then it will come back and then it will moor again. So every few hours you expect a change in status. And so what if you wanted to report just the status changes? How do you do that given the fire hose? Because this is every message from every ship that's visible to the receivers, right? So saying when one particular ship has changed its status is a little tricky, but we can do it because we've initially partitioned the stream of messages into a per vessel group. So this per ship observables says I am going to emit one nested observable stream for each individual ship that I see. And then within that, we're going to say, okay, here is a stream of messages for one ship alone. I would like to just look at this kind of message. So give me the messages of type this. And then I only want to see changes. So the distinct until changed operator in RX says, if this thing emits a value, but the value looks the same as the last one, then I don't care. I don't want to know. I only want to see when it's changed. So basically this says, tell me every time this stream changes, and you can pass in a callback to say what it is you're actually interested in. So it might, the speed might have changed. I don't care. The location might have changed. I don't care. I only care about the navigation status changing. So this is going to filter down that stream of hundreds or thousands of messages the ship sends out down to just the ones where its navigation status changed. And remember, this is all happening within the individual ship message stream. So we had the fire hose. We partitioned that into individual ship streams. Then for each of those individual streams, we said, okay, I'd like to watch each of those and see when something changes. And that's essentially the logic. Now I'm doing a little bit more. I'm saying, actually, do you know what? Every time it changes status, I'd like to see its current status and its previous status. So can you collect this in a sliding window of size 2 for each thing? So every time it changes, I'm going to see the current value and the previous value next to each other. So when I come to actually, print out a message, I can say, okay, what was the previous navigation status? So looking at the first of the two messages, what was its navigation? And then look at the second of the two, what was its one? And then this select many actually flattens it all straight back out again. So having done that per ship processing and filtering and saying, okay, I'd like to chuck away all the messages except where something interesting happens, can you then flatten that back down into one global stream of all the messages from all the ships? And this is much lower volume. In fact, such low volume that none of the ships in Norway have changed status in the time I've been talking. I generally have to leave this running for about 20 minutes unless you run it at the times of day when everyone's leaving or entering the harbour. So it does eventually start doing things. But for me, the interesting thing here is that we've taken a message source that produces thousands of messages a minute and have reduced it down to one that tells me just the things I'm interested in. And this is a good example of the ability to kind of combine global and local inspection, because this distinct until change, this is just looking at an individual ship. Because if I applied this across the whole fire hose, it would tell me nothing useful, right? It would say, okay, the status of this message is different from the status of the last message, but they're two completely different ships, so that tells me nothing at all. I want to know, when did this particular ship change its status? That's what I care about. And this is a technique in RX known as fan out and fan back in again. So I've sort of got a linear stream of all the messages. I fan that out into a series of groups. So it's like I've now got not one stream, but loads of streams. Then I apply processing on each of the streams within that fan. And then after I've done my processing, I merge it back into one thing that contains this low volume but high value event stream. And annoyingly, nothing still has changed. This is not a good time of day to do this demo, but eventually
we'll take your word for it. We believe you.
Which is why I have the other demo, because this one at least is actually showing things. So with this one, I think the map's going to be quite busy now. So it's definitely a real data source. You know, there's definitely things happening here, but they're all doing what they're doing, either in Norway or Svalbard, apparently. So so that's all going on. So there's a similar kind of processing happening in this map one. If we look at this one, you'll see again I'm using group by MMSI to group to basically take the single linear stream of all the messages from all the ships and fan those out into a series of individual observables, one observable for each ship. So it's a grouped observable because it's produced by group by, and then I can specify a stream of processing within that. Now this is slightly more complicated. This one that's rendering the map, it's having to combine several different types of message. It says, I want the navigation data that tells me where it is, where it's pointing, where it's heading, how fast it's going. I also want the vessel name, and actually I want the ship type as well. The color of the arrows is telling me something about whether it's a tanker or a ferry or a shipping vessel or something else. There's a whole bunch of different ship types. And so we're using that to color the map in. So there's three kinds of information here. And all three of those come from different message types, it turns out. So we're basically saying, okay, from my per vessel stream that the group by has given me, filter out all three of these kinds of messages into three independent streams. So here are all the location and speed changes. Here are all the names for this particular vessel. And here is its report of ship types. And then I kind of combine them back together with this RX thing that says, okay, I've got several streams here. I'd like to merge them back into one where I get the latest value from each of the input streams. So combine latest says, whatever these three streams are doing, give me the latest value from all three of them at any one time. And then this ultimately is what feeds into populating the map. So it's this ability to use the various kind of filtering and partitioning and processing operators on your events that distinguishes RX from regular .NET events. You really couldn't express this declaratively with ordinary .NET events. And this kind of compositional approach where you take lots of different small utilities like group by, filtering, aggregation, windowing, and so on, and you combine them in sort of interesting ways to achieve the effect that you want. That compositional style is really the essence of RX. And it's the thing that takes the longest to get used to. Understanding how to combine the ingredients you have to produce the result you want is actually takes some learning. But once you get some familiarity with it, it's really, really powerful.
So I think you sparked a lot of interest here because our chat just started blowing up. There's many questions, and people are looking for more like resources. If you have additional links that you could provide for further education after the fact. Earlier on, I did want to call attention to the fact that someone had mentioned this seems a lot like RxJS. And there's a bit of irony there because that's, this is the predecessor, right?
Yes,
Um,
it seems like RxJS because RxJS was a carbon copy of this. That's why they seem similar. So yes.
There's a question about whether or not this is compatible with the community toolkit, the MVVM, and I would assume so since it's .NET, right?
Yeah, I mean, this is kind of additive. It adds capabilities. So it's if you're using .NET, you can use this. So I think the more subtle question is there any integration between this and whichever UI framework you are using? And that's actually the answer to that is probably less so. It's not that you can't use MVVM. It's more that MVVM doesn't necessarily, well, it depends which particular flavor you're using, but you might not necessarily have intrinsic integration. But what I would recommend is looking at Reactive UX. I'm just going to bring up a web browser here. And
Reactive UI, maybe, because
Reactive UI. That's what I meant to
someone
say.
asked about that specifically too. They said, "Is this, what's the relationship between these two?"
Right, so Reactive UI, this is not a thing I am directly involved in, but we consider them to be a really important customer of RX. So one of the things that we've been doing since we've taken over is trying to make sure that we are doing our best to address any issues that they have with the RX code base. So we've done a few things that are sort of specifically for them and anticipate doing more of that. So what is Reactive UI? Reactive UI is a .NET framework for doing user interface logic specifically with RX. It is designed with RX at its heart. So if you want to do like MVVM with RX, then Reactive UI may be exactly the framework you are looking for. And I would strongly recommend going here and having a look at it, because this does give you all the power of those two kind of concepts combined together. And it's an amazing piece of work. There's a whole lot in here. It's really, really good. So yes.
Awesome.
Go look at it.
And then Tom is asking about the IQ observable.
IQ observable is how we pronounce that.
Yeah. Okay. Perfect.
Right. Okay. So let me. How best to talk about
I
this?
thought that was a typo, the Q there.
Nope. Yes, people normally do. What is observable?
I just assumed that it was probably like the iQueryable, where you like basically transmit your intent over the wire. Is that?
That's pretty much it. But
Okay.
let me show specifically what it is. So I should probably quickly just actually introduce the core interfaces that are at the heart of RX. So if you have, so I've just added the system.reactive library to my project, so I can do, for example, iObservable of long is ticks equals observable. Oop, hello.
Well, to be clear, the iObservable and iObserver interfaces aren't part of RX.net. Aren't they system?
They are the heart of RX.
Okay,
they're not at the heart of. They're not part of System Reactive though. They are at the heart of RX, but they are built into the .NET runtime libraries.
Right. Okay.
But they are still the heart of RX.
Yes.
It's just they happen to be built into the framework. Right. So let me just quickly get an actual example so I can show something specific. So this says I would like an iObservable of type long, which I'm going to ask RX, is the RX library, system.reactive, to build me one of those just by giving me a new tick every second. And if I just subscribe to this, right line. This is sort of absolute hello world RX. So I've got an observable source and I've subscribed to it with an event handler that says what I want to do. And I had to somehow make sure my process doesn't exit because it's all asynchronous. So I'm just going to do a console.read line to keep things alive. And if I run this, this will start doing a tick every second. So that's sort of about as basic as it gets with RX. I've said I've got an observable source that's raising an event every second. So what does this actually look like? So iObservable is a pretty simple interface. It has a single method called subscribe, which I sort of called down here, except I actually called an extension method that helped me a bit. You subscribe to an iObservable by providing an iObserver. How do you observe? You have an observer. And what this looks like is a method with an interface with three methods. on next, on error, and on completed. I'm sort of listed in the least helpful order they could possibly be listed. But anyway, on next is called every single time the source has a value for you. So each time you see that tick, that's because the observable source called on next on my observer. If something goes wrong, it's going to call on error. And if it has run out of things to give me and knows there will be nothing more, it calls on completed to let me know that it's done. Not all sources do that. Observable.interval will go on for as long as you care to remain subscribed to it. And that's pretty much it. That's the whole of the basic programming model. So observables are things you can subscribe to, and you have to supply an observer or use some utility that implements iObserver for you, which is what I've done here. This just wraps my delegate in an iObserver interface and calls it. So that's iObservable. And so this is the basics. So what about iCobservable? Not a typo. So, observable, I mean, we can basically write the same thing. So what's the difference? Stick a Q on the end so that compiles. So iCobservable looks pretty, I mean, it implements iObservable, so it's very similar and doesn't add a great deal more. So we've got iCobservable inherits from iObservable of T, so you can do anything with an iCobservable that you can do with an observable, and then it also inherits from this non-generic base interface, which will look kind of familiar to anyone who's done any iQueryable work in the world of link to like data sources. And the basic idea of this is that when you have an iCobservable, if I can find, actually, sorry, this is not a great example, but the basic idea with this, sorry, I've realized I should have done something more complicated and we're going to run out of time if I do it. But the basic idea is that rather than actually building runnable code, it causes the C# compiler in general to emit query expressions. So you may be familiar with doing this sort of thing. If you say, I'd like a function called add, which just, sorry, actually, let's call it D for double, goes to x times 2. That just generates some code, right? That just gives me a function that has the IL for that code baked into it. But if I wrap it in this, I get something completely different. I get a thing that describes the shape of this expression. So if I let that run to there, and we, oh, what's happening? Oh yeah, it didn't like my code because I forgot to do a thing that I don't have time for. Right, so if we just let this run and hit that line of code, what is D here? Well, D is actually a description of my expression. If I just zoom in a little bit on this so people have got a chance of seeing it at home. This doesn't work very well on multi-monitor systems. Let's do my best. So D is, but you can see it knows what the expression is. It says it's a lambda that goes to x times 2, and we can actually start to drill into this. And it's, if you drill down inside it, it will be a complete description. It says, okay, the body of this expression is actually a multiplication operation, and the multiplication's left-hand operand is a parameter called x, and its right-hand operand is a constant whose value is 2. So essentially, rather than turning that into code, it's just built an object model that is a tree of objects describing what the expression looks like. Why is that interesting? That is interesting because it enables you to move the expression from one machine to another. So there is a related project that we also maintain called Reactor, which is spelt Reactor with a Q. And if you want to find out about this, you should go to ReactiveUI.net, which is this site here, ReactiveUI.net. And this is essentially RX in the cloud. This is the way of hosting long-running subscriptions. So if you want to have a thing that, for example, observes like a temperature sensor in some sort of piece of industrial plant, and that raises notifications when something goes out of range, you want that to keep running, you know, forever, really, for years at a time, and you don't want it to shut down just because you had to apply some updates to a device. And so Reactor builds on top of RX to say, well, okay, we're going to need persistence. We need things to be able to be remembered. We need durability. So if one machine goes down, we can bring it back up again and have all the same state there as we had before. So that's what Reactor does. But to be be able to do this, it needs to know exactly what you're doing with Rx. So rather than you just having compiled code that represents what you did, it needs to see the description of what your query looked like so that it can reconstitute it if it has to reboot a server. Oh, look, hang on a second, I have to show you this. Once I can move it onto the screen. It was real.
It's still running.
Got a message.
I love that. You just had to leave it running to prove it.
Yeah,
like,
I was off on another
you.
screen all that time. It's finally an interesting thing happened.
So what's really interesting about Reactor and like the expression trees and transferring the intent of your Rx is Jose was actually asking, how does Rx relate or work with like Microsoft Orleans or Akka.net? And it sounds like Reactor is kind of doing that, right? To an extent.
So how does it interact with those other sorts of frameworks? They are quite different programming models. So with Reactor, you don't put any of your own code into the compute farm that hosts Reactor. You just describe the queries you'd like it to run, the subscriptions that you want, and then you tell it what the sort of ingress and egress points are. So you might say, okay, I've got like an Azure Event Hub here. I'd like to connect that in as the observable source for this query. Here's my query, and then please feed the results out through this Azure Event Grid, for example, or whatever it is you might want to do. So the stuff that runs inside of Reactor is purely the Rx expression. So like these queries I've been showing you, the group bys, the filtering, all that stuff, that's what runs internally. You don't get to actually upload any of your code at all into those things. Whereas things like Orleans and Akka, it's much more of I deploy my code into this environment, and then it provides me with a programming model that makes certain guarantees. So they're only kind of similar at quite a high level of abstraction, in the sense that they are well-defined models for managing long-running computations on a server farm, but the actual mode of consumption is very, very different, I would say. So I know there were some discussions between the Orleans group and the original creators of Rx. I don't know if anything has come from that. They may or may not have plans, for all I know, about stuff there. But it will be interesting to see what might happen, because you could easily imagine wanting to combine these two, right? So the idea of having, a Reactor-style stream that then feeds into one of these other programming systems models, and then use those as a source downstream. That would be great. Today, I'm unaware of anyone having done that with this. It's certainly technically possible, but it's no one I know of has done the work, or if they have, they've not been public with it.
And very timely, Paul's asking about Reactor. He's like, is it sort of like a durable task framework?
It is a durable subscription framework. So the thing that it actually persists. Let me go back to my previous example. Let's stop debugging. And let's load the last example that I did that actually worked. The per ship status change one. So the point at which you do a subscribe. So this thing down here, this is the point where I'm saying, okay, I've defined what my query is, but now I actually want to subscribe to that and do something in response to it. That's actually the thing that gets captured by Reactor. So until you've actually subscribed to a thing, it doesn't really exist. It's kind of like a tree falling in the forest. Until someone subscribes to listen to it, it doesn't actually happen. But it's actually a bit more real. The tree won't even fall over until you start listening to it. So it takes that and sort of slightly overstretches the reality of it. But that's how it is. So when you define an observable source, like I've done here, nothing's actually happening yet. I've just said, here is the definition of this observable that tells me about the ship status changes. So this is all just an expression that says what to do, but it's only when I subscribe that anything actually begins to happen, because up until that point, there's nowhere for the data to go. So why would it do anything? And then Reactor with the Q takes that a level further and says, we will create a persistent thing at the point where you subscribe. And enhances this with things like identifiers. So a subscription actually has a URI associated with it, so you can go find it again later if you need to.
So I'm just now realizing that we're approaching the top of the hour, and we haven't even talked really about modernizing very much, right? Like that was the
Yes.
emphasis of this episode, and we're gonna definitely have to have you back on because this is great. There's a lot of engagement, a lot of great questions.
All right, I'd like
Um,
to talk very quickly about what we have done then, if I may. So,
Absolutely.
Please.
so towards the end of last year, we approached the previous owners of RX because it had kind of become moribund. So up until .NET 5, they'd managed to do a very good job of keeping, releases going again and again, but for various reasons, all the people involved just didn't have the time to keep on that treadmill. And so we went in the space of only a year and a half to RX.NET being apparently completely up to date to people thought it was dead because it hadn't had a release. It was particularly unfortunate that RX5 had the same version number as .NET 5, so everyone thought that when there was no RX6 that it was, it had died. That wasn't actually true, but it was unhelpful. So Engine stepped in and they agreed to let us to work on this thing, and so we became maintainers of the project, and we set out a roadmap for what we wanted to achieve. So back at the beginning of the year, we sort of said, okay, here's our long-term vision. So here's all the various different flavors of .NET that we need to think about. There's .NET Framework, there's .NET, there's Xamarin, there's UWP that's been supported in RX forever, and we're not about to remove support for that. There's Unity, and so we had to think, well, okay, what do all these different platform life cycles look like, and then what do we have to do to accommodate that? And so we then said, here are a bunch of problems that we know about as well. So there have been no releases for a while. The software didn't actually build if you opened it on current versions of the SDK and the tooling. There are certain problems that UI frameworks have been having with more recent versions of .NET. So it doesn't play well with trimming. It doesn't play well with ahead of time compilation. And there was an ever-growing backlog of issues that was getting no love. Also, there's a whole async variant of RX that's been in an experimental state forever and hadn't been released. So we said, okay, we're going to address these things over the next year. And so we said, we're going to get a new release out. We are going to bring it up to date with current tooling. We're going to fix the code bloat problem. We're going to deal with it, start looking at the backlog, and we're going to do async RX. And we've achieved most of these. So we did that. RX6 came out earlier this year. It builds properly on the current versions of everything. This is the one we haven't dealt with yet. This is a hard one, avoiding code bloat problems on things like Avalonia. We are making progress on this. There is still a big backlog of issues, but we do now respond to them. And there is a preview version of async RX now available on NuGet, so you can experiment with that if you want to, but it is a preview. It's not beta, it's way before that. It's not ready for consumption yet, but you can go and look at it. So we then go into more detail on that, but that's essentially what we've done. We've managed to achieve 4 of these 5 goals, and it's not the end of the year yet, so we're hopeful we will actually manage to do all these things. And we're open to requests about what to do in the longer term than that, but we wanted to get these things done because they were the ones most pressing for the community. So yeah, that's what's been going on.
Yeah, it seems like the next pressing issue would be to have your guys' own conference. Do it.
Yeah,
RX Conf.
I'm not sure my boss would be up for sponsoring that. I can ask him, but
you can come anytime. You can come back and do more sessions, and then we have a mini conference.
There you go.
Yeah, I can talk for days about this, as you've probably already noticed.
Yeah. Awesome.
Yeah. So one last thing I wanted to ask you really quick. In the beginning, you mentioned one of the things that your team was working on was improved education. Could you talk about that really quickly? Because I'm sure folks, when they leave the video, they'd love to know, okay, well, I want to learn the thing. Where can I go and learn about some of the stuff that you guys are doing?
Right, yeah. So this is unfortunately a work in progress. So we have this thing. There is this site intro to RX, which you did link to earlier, but we haven't updated it yet. So I'm open at a random chapter because I was working on it today. So we are basically going through this, and actually the content as it is, it's not bad. It's just a little bit out of date. So it goes through all the parts of RX. It talks about the core types, iObserver and iObservable, talks about how to create observable sources, talks about all the different ways you have of processing data, and then goes on to more pragmatic concerns like how do you deal with threading, how do you get back out into the outside non-RX world, how do you handle errors, how do you do testing, various things like that. So there's a lot of information in here. We are probably still a couple of months off from actually having the updates out there, I'm afraid. So it's not yet live. If you go there today, you will find the very old content, but we are working on it, and we want to get that out there as soon as we can. But I also have to do paying work from time to time, so it's going to be a little while. And I'm also working on an update to my programming C# book. So so we're getting through it as fast as we can.
You're a busy man.
Yeah.
Awesome. I think from the chat, you can see that there was a lot of excitement. I think you got the wheels on each person's brain spinning because like people are thinking about how can they integrate into their projects, thinking about how can I use this. So it's been awesome. So please come back at any point that you want to share more. And like we I think like we can do more demos with other like Blazor or something like what people like to see. So I want to thank you for coming here today, but also thank you everyone for watching and being such a great community and asking questions. That's what makes the show like shine. And you can go and check out other great .NET live streams and videos at .net/live. And tune in next week. We're going to have one of our hosts, Luis Quintanilla, and he's going to be talking about OpenAI for .NET developers. So thanks for hanging out with us. And if you want, you can also submit your own talk like Ian did. And it would be awesome to have you on the show as well. Thank you, everyone. Take care.
Thank you.
Thanks
Bye.
very much. Bye.